Hi and welcome. Here we are going to look at analysis of variance and comparing means of 3 or more populations. So that's what we're going to do. So let's quickly take this question. They said, given the following sample information, can we conclude that the treatment means are equal at 0.05 significance level? Now, what do you mean by this? You see, the 0.05 means 0.05, okay? 0.05, or it can be written as 5%. You have to be very careful, okay? So you should be very careful about that. So there are 5 steps. This is an hypothesis test, and there are 5 steps like you have to go through to do this. Are you with me? So the step 1 is to state the set of hypotheses. So you have to state the null and the alternate hypothesis. Are you with me? So the null hypothesis says that what the treatment means are equal, meaning the mean of this is equal to the population mean of treatment 2 is equal to the population mean of the treatment 3. And then the alternate says that what not all are equal. Another way of writing the alternate, which is H sub 1 is H sub A. Okay, that's another way of writing it. Okay, then the reason why I also use not equal, or I didn't use like mu1 as, let's say mu1 is non-equal to mu2, also non-equal to mu3. You can write it like this as well, okay? But the reason I didn't write it like this is that when we say something is not equal, it could be that, you see, there are 3. It could be that 2 of them are equal and the third person is not equal to them, or all the 3 are not equal to each other. This is not equal to this and not equal to this. Or it could be that 2 of them are equal and only one is different. So that's why I write it in statement form that not all are equal. Are you following? So step 2, you have to choose a level of significance. So you can choose a level of significance 5%, 1%, or wherever. Are you getting it? But this question has given us a significance level of 0.05. So you have to use what the question has given to you. So alpha is 0.05. Are you following? So step 3. In step 3, you are going to state the test statistic. Is it Z distribution? Is it T distribution? Is it F distribution or something? So for this particular one, the test statistic is the F distribution. Are you following? Now the F formula is this, okay, but it can be written as, at times you'll be reading some slides, you see MST over MSE, okay, MST over MSE. What I want you to know is that MST is the same as MST is equal to SST divided by K minus 1, and MSE is equal to SSC divided by N minus K, okay? Yeah, and please, it depends on the method you're using. We have different methods for doing this, which I have videos for them. You can watch them later after this, okay? There is one particular one. I use SSA over C minus 1 divided by SSW over N minus C. Okay, we have different ways of writing them. That one is, so this SST means sum of square treatments, okay, and the other one I was talking about should be sum of square among, okay, and SSC means sum of squares error, okay. Then MST means mean square treatment, and this MSC means mean square error, okay. You should just know. And this K stands for number of treatments, okay. K stands for number of treatments. So there are 3 treatments here: treatment 1, treatment 2, and treatment 3. So K means 3. Are you following? And then N means number of observations. So how many observations do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sample size, okay. So N is 12. So let's proceed to step 4. In step 4, you are going to determine the decision rule. Now, to determine the decision rule, are you following? To determine the decision rule, what you have to do is to what? To actually find the critical value. And to find the critical value, you need the degree of freedom of the numerator and the degree of freedom of the denominator. Now listen, this K minus 1 is known as degree of freedom of the numerator, and then N minus K is degree of freedom of denominator, okay. So df in the numerator is equal to K minus 1, which is 3 minus 1 equals 2, because we have 3 treatments, so K stands for the number of treatments. And then degree of freedom in the denominator is n minus k. And n means number of observations, which is 12 in numbers. And k means number of treatment, which is 3. So 12 minus 3 gives you what? 9, isn't it? So we have 2 and 9. So numerator is 2 and denominator is 9. So how do we use this to find a critical value? So you take your table, the F table. Are you with me? When you take the F table, check the F table properly. There is one of the F table, they've written alpha equals 0.01, or at times you see 1%. 1%, okay, 1%. And then look at this one. They've written alpha equals 0.05. At times you see they've written 5% in some. Please check it before you use it. Okay. The question gives us significance of 5%. So meaning you should use this one. In exams, when I give you question in exam and I'm giving you the tables, I'll combine all the tables for you. I'll give you all the tables we have. I want you to use the right one that you see you can use. Okay. So don't expect them to always give you the 5%. They can give you all the tables we have. You have to use the one that fits the question. Okay, so always check it properly before you use. Are you following me? And then, how do you then find a degree of freedom? You check this. This is the numerator. The numerator is 2. You see, they've written numerator here. And denominator is what? 9. Are you following? So what you do is that you trace them. Okay, where they will intersect. Okay. So it gives you what? 4.26. So this 4.26 is your what? Is your critical value. So F sub alpha, okay, critical value of F, okay, is equal to 4.26. Okay, so to state the decision rule, are you with me? Your decision rule will be that if F, this F stands for the F here, we call it computed F or calculated F. Are you with me? Computed F or what? Calculated F. So your decision will be that if this computed F, just raw F, is greater than the critical value of F, which is 4.26, you should reject HO. Okay? But if it is less than that, you do not reject HO. Some people write it as if F is greater than or equal to 4.26, reject HO. And if F is less than 4, since you've brought equal to here, you don't bring it here again. If F is less than 4.26, okay, you do not reject HO. You can also write the decision rule like this, but I just choose to write this. If F is greater than 4.26, reject the null hypothesis HO. But if F is less than 4.26, which is the critical value of F, you do not reject the null hypothesis HO. Are you following? Then, what do we then do next? The next thing we have to do is to compute the F. We should find the F to check whether it's greater than the critical value of F or lesser, isn't it? So how then do we compute the F? So that's what we want to do now. Now remember, F is equal to SST over K minus 1, all divided by SSE over N minus K, isn't it? So, please, we have different methods for doing this. But this is one of the methods I'm using. If you want to learn the other methods, I have videos for them which you can watch, okay? So, for this method I'm using, for just this method, this is how I'm going to do it. So, follow it this way. Now, the first thing to do is to find SS total. Okay, the first thing to do is to find what? SS total. Please, SS total is different from SST, which is SS treatment, sum of square treatment. And this is sum of square error. Okay, so SS total is different from sum of square treatment. Be very careful about that. So SS total, its formula says what? Sigma x squared minus sigma x all squared divided by n. What do we mean by this? When we say sigma x squared, it means that you should square each axis. This is an x value, each observation. Okay, each observation is known as x. So 8 square, 11 square, 10 square, 3 square, 2 square, 1 square, 3 square, 2 square, 3 square, 4 square, 5 square, and 4 square. You should square each of them and add them together. You see what I've done here? 8 square, 11 square, 10 square, going. Then, you can punch all this on your calculator and get the answer straightforward. Or because I'm teaching, I just decide to do them step by step. So 8 squared gives me 64, this, that, this, going. Then you add them together, you get 378. So meaning that the whole of this, sigma x squared, gives you 378. Are you getting it? The sum of x squares, okay, you square each observation and you sum them together. That's the meaning of the sigma. Minus sigma x all square. What do we mean by sigma x all square? Meaning that sigma x itself, like each observations, add all of them together. So to easily get them, let's add only this place. 8 plus 11 plus this gives you 29. Is that it? Yeah. Then this plus this also gives us 11. When we add all this, we get 16. So when we add everything together, we get so that's what I'm doing here. You should add each observations, 8 plus 11 plus 10 plus, you add all of them together. Okay, you can put them on the same calculator. 8 plus 11 plus 10 plus 3 plus 2 plus 1 plus 3 plus 2 plus 3 plus 4 plus 5 plus 4. You add all of them together. When you do that, you are going to get 56. Okay, you get 56. So when you get a 56, what this means is that to find sum of square total, you substitute 378 in place of this to get 378 minus. Now we say sigma x squared. So sigma x is 56 squared. Do you get it? Divided by 12. Now the square is only affecting the numerator, please. It doesn't affect the denominator. I hope you are following. So you are going to get 378 minus, when you punch this on your calculator, 56 squared divided by 12, it gives you 261.33. Check it out if I'm not mistaken. Okay, then 378 minus 261.33 gives you what? 116.67. That's 116.67. So sum of square total is this. Okay, then next you find SST, which is sum of square treatment. Okay, to get sum of square treatment, the formula is sigma t sub c square over nc minus sigma x squared over n. What do we mean by this? What we mean by this is that the total of each column, okay, or the total of each treatment, okay, the total of each treatment square. That's why we brought the sigma. Okay, the sum of the total of each treatment square divided by the number of observations in each treatment. Are you following? Let's look at it. What this means is that, what is the total of observation in treatment 1? The total of observations in treatment 1 is 29. So it means take 29 square divided by the number of observations in treatment 1. That's why we've written NC, each column, okay? Each column, column 1, column 2, column 3. Do you get it? Plus, what's the total number of observations in treatment 2? It is 11. So you take the 11 square divided by the number of treatments, okay, number of observations in treatment 2, which is 1, 2, 3, 4, 5. So it's 5. You get it? Plus, what's the total of all observations in treatment 3? 1, 2, 3. There are 4 in numbers. What's their total? Their total is 16. So you have 16 squared divided by 4. Minus, before you bring this, okay, before you bring this, 56 squared, which you already know what sigma x is from here. 56 squared divided by 12. So when you do this, okay, you get the whole of this. When you add them together, 29 squared over 3 plus 11 squared over 5 plus 16 squared over 4 gives you 368.53. 368.53 minus this also gives you 261.33, isn't it? So when you subtract, you get 107.2. So that's the answer to SST, sum of square treatment. I hope you are following. Then you then find sum of square error. Are you following me? Then you find what? Sum of square error. To get sum of square error, please, per the method I'm using, I told you we have other methods. And in other methods, we have formula for sum of square error differently. But here, per the method I'm using just here, since you know sum of square total and you know sum of square treatment, you can find sum of square error by saying sum of square total minus sum of square treatment. It will give you sum of square error. So what did we get for sum of square total? We got 116.67 for it. So we substitute it minus sum of square treatment, you get 9.47. So that's sum of square error, 9.47. I hope that's clear. So we've known our sum of square error. So the next thing to do is to find f. Now, the formula for FC is what? SST over n minus n over k minus 1 divided by what? SSE over n minus k. So if you go back, we got SST to be 107.2, isn't it? And SSE is 9.47, so we substitute it there. So 107 divided by 0.2 divided by k minus 1, which was 2, degree of freedom of the numerator, isn't it? All divided by, what was the sum of square error? Sum of square error was 9.47, isn't it? Divided by n minus k, which was 9. Do you get it? So when you put this on your calculator, okay, or when you just solve the numerator separately, 107.2 divided by 2 gives you 53.6, isn't it? Divided by 9.47 divided by 9 gives you 1.0522, okay? So when you divide, you get 50.94 as your computed F. So since the computed F, which is 50.94, is greater than the critical value of F, which is 4.26, then we reject what? The null hypothesis, HO. Okay, if you want to follow the decision rule, you are going to reject it. So since you rejected it, the HO was the claim, right? That the treatment means were equal, right? So there is sufficient evidence to reject the claim at HO, okay? There is sufficient evidence to reject the claim HO. Okay, we have sufficient evidence to reject it. That's why we've rejected it. So if we've rejected it, you have to conclude that hence we cannot conclude that the treatment means are equal at 5% significance level, or therefore we cannot conclude that the treatment means are equal at 5% significance level. Since we've rejected it, HO says they are equal, but we've rejected HO. We ended up rejecting HO. So since we've rejected HO, we cannot conclude that the treatment means are equal. Is that right? Now take a look at this table. At times you see this table too in exams. Okay, look at the table. You see this. This table is just a summary of everything you've done. They want you to prepare it in tabular form, like what you got for SST. They wanted you to write it in this part: treatment, sum of squares, okay, source of variation, sum of square, degrees of freedom, mean square, F. So sum of square, so sum of square treatment, okay, SST, you get it. Sum of square error, SSE. Sum of square total, do you get it? So what you got for SST was what? SST was what? 107.2. They wanted you to write it in this column, 107, in this cell, sorry, 107.2, right? And what you got for SSE, they wanted you to write it here, okay, 9.47, okay. And you know, when you add SST and SSE, you get SST, which is what? 116.7, sorry. It can also be 0.7. So k minus 1 was what? 2. That's 3 minus 1, which is 2. N minus k was what? 3, right? Sorry, 9. Sorry. N minus k is 9. Then n, sum of degree of freedom of total should be what? 2 plus 9, which is 11. Or another way is what? Number of treatment, 12 minus 1. You get the same 11. Have you seen that? So it's either you add the degree of freedom of numerator and degree of freedom of the denominator to get 11, or you take 12 minus 1. Okay. Then mean square, okay, mean square treatment, MST is equal to SST over k minus 1. So what was your MST? MST was 53.6. Okay, MST was 53.6, so you can fix it there, 53.6. okay, and then MSC was what? MSC was 1.0522. okay, so 1.0522. so that's what they wanted you to do when you get this kind of table. So to get F is MST divided by MSC, isn't it? MST divided by what? MST, and that gives you 50.94, isn't it? So they just wanted you to put it in tabular form like this. So at times I can give you this table in exams and I'll omit this, I can omit this and give this and then you see they will omit some of them and put some of them there, and they want you to find the omitted ones. Okay, you should just know how the thing works. Okay, I've omitted this SSE and I've given you this and this. You should know that SSE should be equal to SS total minus SSE. Are you getting it? Let's say I've given you 11 here, I've given you 9 here, and I didn't write anything here. You should know that 11 minus 9 will give you this place. Do you get it? Yeah, so you should just know how the table operates, okay? So you can draw it down, okay? Yeah, so that is the end of our lesson for this. So if you want to know other methods, do well. I have videos on them on the same YouTube channel, and make sure you watch it. Do well to subscribe to our YouTube channel as well, and share with your friends who would like to understand this topic better. And thank you for watching. Have a nice day.